they know structural masonry, so it's based for non-engineered types. So we're looking forward to that presentation and be very informative. But at this point, we had Cora. We thought Cora was going to be here. That's Kirk is going to talk to us about sales tax issues for the city of Springfield.
Thank you.
Yep, slide, the description, you can get the credit. It's back by the table there at this point. So.
This is sales tax.
My name is Kirk. I'm with the city of Springfield. I'm the assistant director of public works. And April 2nd, we're going to have an election here in the city. And the renewal, and I repeat, renewal of the 4% capital improvement sales tax will be on the ballot. That's very important to public works. This brochure kind of talks about the history. This tax was first put into place in 1989, so it's been around 30 years. With that, council decided rather than do a 3-year renewal, go ahead and do a 20-year renewal. So that's what's on the ballot. Now, we haven't done what the DOT did and planned projects in advance, 20, 15 years. We only went 5 years, so the accounting document you see in the middle just covers projects that have been programmed out 5 years. We did take into consideration certainly safety, economic development, environment, connectivity to other modes, transportation. We got input from the public. We also got input from city utilities, other utility providers, police, fire, those folks. Major projects are on like the third page in the orange. Proposes building a 3-lane section on Galloway Street from Luster down to Lone Pines, reconstruction of the division between Glenstone and National, new intersection at West Bypass and Kearney. That's cost share with the DOT, so we're not picking up 100% of that. We're building a sidewalk at the division west of Kansas. That's a cost share with city utilities. Actually, they're probably paying for about 80% of that project. And we're just providing the match for their grant. Battlefield and Lone Pine will redo that intersection, provide AIA ramps. National and Sunset, similar reconstruction of that intersection. Then there's 2 bridges here. We don't want to get behind on bridges. You can't hardly catch up. Scenic over Wilson Creek. That bridge is about 20 foot wide. It's old. It has a lot of pedestrian traffic too. When there's a lot of cars, it's kind of hard to cross a 20 foot wide bridge on foot. So we can get that done. Walnut Street over Jordan Creek, that bridge was built in the 20s. And it needs to be replaced as well. We have various programs here that provide us a lot of flexibility. We have a lot of demand for sidewalks, not only for schools, but within neighborhoods. We have a cost share program, and we work with MoDOT, Green County, developers. Somebody wants to bring new jobs to our community, we'd be happy to cost share on road improvements to bring them here. Marking and signing, we've got a traffic signal program. Certainly street maintenance is important. With this program, we're going to take $3 million of federal funds and put it with our funds for a total of about $7.7 million in the program. In here, project number 12, kind of in the middle, it highlights the roadways are highlighted, Battlefield, Sunshine, the National, the major resurfacing projects that should bring our system up pretty quickly. Anyways, I want you to vote April 2nd. I don't want to take up too much time. Y'all have any questions? Yes.
Seems like we just voted on something, another tax recently, another sales tax. Was there an 8 cent?
We had the level property tax that just went through that took care of a lot of city facilities.
Okay. Okay.
Yeah.
And that's a
property
property
tax.
tax.
Fire stations right now for design.
Okay. And this is sales tax.
Yeah.
We voted about a year and a half ago and it passed. And it went to took it I don't know what the food one is, but the non-food went from like 7.58 to about 8 something. What was that?
I didn't tell you.
Anybody remember that?
It was to shore up the police and fire department's, retirement fund.
Well, that was the 3/4. Well, I don't know when the last was reviewed.
Is that gonna stay on forever?
And if you remember, last year after the bond for the school district, the city assessor, since your new assessment and your property value went up.
I guess my understanding is, for the police and fire pension, they can't renew it again, they have to switch it up somehow. Apparently there was some kind of clause that says it's only renewed one time, and it wasn't renewed one time. Any other questions? I'm not good at all the other stuff, but I'm good at water stuff.
Kurt, are you gonna be hanging around for the lunch?
Yeah, I'm gonna go ahead and watch this masonry presentation, appreciate the opportunity.
So if you have more questions, maybe
Yes.
after the meeting, you can go to the third.
Yes, appreciate it.
Let's turn it over to Kate. She's going to talk about some of our March, April, and May upcoming events.
We have quite a few things coming up on the forefront. The Bow Arts Ball here at Drury on the 22nd next month. There'll be a study session with the Architects Forum at Springfield Brewing Company on March 25th. And then also an out-of-town event on the 27th. I think that's a Wednesday. It's our legislative day. It's free. You go if there's, I think, some continuing education credit and an opportunity to talk to your legislators.
I've got a flyer right here. If you're interested in doing that on the 27th, I'll see me afterwards and share it with you.
Yeah, and let us know. Usually there's a carpool of people that go up there, so guys together. April is pretty busy. I'm personally working with several people in this room on it. We have Architecture Week coming up the 5th through the 12th. So Drury will be having a Practicing Optimism Symposium that Friday from 1 to 4. And then we're going to be participating on at Park Central Square and on C Street with that first Friday Art Walk. We'll be displaying some of the design award winners from last year. So if you want to swing by, they'll also be displayed that whole next week at those locations. So you can go swing by anytime. We're going to have another, I don't know if you remember about a year and a half ago, we had a little film fest with some short films. The National AIA has a film challenge every year, and so we basically pull out of that, and it features projects from all across the world, free of charge. It's at the Moxie that Sunday night at 6 p.m. I will be sending out notifications so you can sign up through Eventbrite. We're going to have a construction tour, the new Interpress office. Some of you might know about this on South Campbell, I guess it is. It's the old fire training center. Am I saying that correctly?
Fire station.
Fire station, yeah, exactly. But it's made quite the improvement. So if you want to stop by and help him celebrate his new office, we're just going to be serving beer. And then Drury's also having their award ceremony and crawfish boil that Friday. And then we're going to cap it off by congratulating Brandon Dake on his elevation to the College of Fellows that night. Location to be determined, but probably up on C Street. So I'll be keeping you posted on that. In May, we're confirming, but we're probably going to be participating in Arts Fest on have a booth. Our goal is to not make it a stagnant professional booth. It's just we're contemplating doing. I don't know if you remember the old Charlie Brown psychiatric, like 5 cents for advice thing. We might be doing something of that nature. There's some people that are going to be in charge of that. And then we're going to have a section set up for kids where they can build with building blocks there. Just a way of getting out in the community and kind of explaining what architects do. And then also, Brad Palmer with ASHRAE is having a meeting that he's opening up to the architectural community and construction community. Anybody that wants to come talking about is this correct, Carmen? Does this look all?
It sounds familiar.
Yeah, no dates. Still a little ways off, but May 7th, it's a 505 East Traffic Way. Because we're not, I don't think most of us are ASHRAE members. It is $15 to come to your lunch in advance, $17 at the door. Same times, 11:30 to 1, and then we'll have another. So we got all that. We'll post it on the website too, so that everybody can know that.
Yeah, I would encourage everyone to visit the website, and as more information comes out, I'll usually be blasted out to everybody on the mailing list. So, as you know, I'm going to keep reminding you, and as I will the board as well, we've established 4 committees this year. Diversity, recruitment, community engagement, communications, and member celebration. So we're covering a lot of the community engagement and the member celebration by a lot of these things we just talked about and what we're discussing at these meetings. Communications and messaging, we're still working on that aspect of it. That's more of a branding thing, try to get on our website. Some of those, that has to be coordinated with the AIA National standards for the website. Diversity and recruitment, Amy, do you want to say anything about that today, or?
Just that we have a really vibrant group that's excited about trying to bring in groups that we already have in our components, especially young people, because we're seeing quite a decline in the I generation joining the AIA, and also just support for women and minorities components. We have about 6 people, and each one is taking on a different aspect. We're going to send out a survey, hopefully in the next few months, trying to find out some of the reasons behind why we're losing membership with the younger generations, and how to get people back involved in AIA. So be on the lookout for that.
I know they're digging into the data, the demographics, the AIA, local, national, state, so it should be.
Yeah, we're hoping
a lot of
to
information.
create some graphics where we get a better understanding of what we actually have in our group.
Then we're going to continue to kind of see this slide as we go on throughout the year. But we want to celebrate what we do every month, at least, at these meetings. So my email address is down there at the bottom. So feel free to write it down. If you know of somebody that has some achievement that they've accomplished, that yourself, you've done it, your firm has done it, somebody's been recognized, just email it to me. We want to try to keep a running list of this stuff. And at the end of the year, I think we'll all be pretty surprised at what everybody as members has accomplished over the year. I do want to, we've carried this over a couple months now. I don't know that Emily is here or Kalea is here, but they're both a product of Amy's efforts, reaching out, getting this group together. These young folks had a passion for that topic, and they're now AIA members as a result of it. That's the type of effort we really need to expand our membership and that diversity, bring those other thoughts to the table.
service the architectural community along with the masonry community here in town and just try to promote proper use of masonry. So that's why we have Beth here today to elicit some responses and thoughts from everyone.
Well, I just want to say, AIA Springfield Board, we appreciate you guys' involvement in AIA. Without our allies, we wouldn't be able to do a lot of these things that we do, so thank you for that. Additionally, we have our 3 major sponsors for this year: Turkish Building Solutions, Paragon, Cove, and Associates. Again, that's kind of overlaid over the sponsors that take care of lunches and other events for us. So with that, we're going to turn it over to Beth, and we'll get started with that program.
Thank you, Stephen. Let me get my presentation switched over here. That's okay. Oh, were you going to do it? All right. So good afternoon. I'm happy to be here today, and I appreciate your taking time out of what is spring break, which I didn't know before I came, to come to the meeting today. My presentation is all about what architects need to know about structural masonry. We like to deliver this presentation in a non-technical manner, basically providing a lot of information about how masonry can be used in construction projects today. And let me get that on. Our learning objectives will be to review the structural masonry basics. It's effective, it's economical, it's efficient. We want to discover some updated design criteria and design methods for masonry. We'll include a look at some of the updates to the IBC 2015. And we'll learn to design economical masonry walls. Again, just in the big picture, we're not going to go into design numbers for these examples, but just about some things that can be avoided or things that can be added that you may not necessarily think of. And then explore some structural masonry details related to that design to see, again, where you could find value in your building. So there's a huge misconception in the field of building and construction today that masonry is not a good building material. At least that's what I see on a day-to-day basis. And people say it's too expensive, it's too old, you know, there aren't any new techniques to be used, it's not attractive. And I'm here to challenge all of those beliefs because masonry is completely flexible, it's very cutting edge, and we need to give it some more credit than we currently are. So a little bit about me before I get started. I'm a structural engineer, and I'm licensed in California and in Arkansas, which is where I currently live now. I came up today from Jonesboro. I got my undergrad at Notre Dame, and then I moved out west and got my master's at Stanford. And that's where I started my career. And so for those first 10 years of working, I was a consultant in Southern California. And then I joined Bentley Software. I don't know if you're familiar with Bentley. They do a lot of engineering software, but they also have MicroStation, which is their big drafting product. And then I joined Force in 2016, where I've been ever since. And Force Consulting is a team of engineers. We all come from a variety of backgrounds, and we all have a pretty diverse experience in design. We've all worked extensively with masonry. We're a consultant to the International Masonry Institute and have been since 2010. And like I said, a lot of us have specialized in masonry design in our careers. So the fact that I started my career in California will lend a little perspective to this presentation for you. When I started designing, we were working on every project under the sun. We had military barracks, we had park structures, restrooms, comfort stations, pavilions, that type of thing. Schools with gymnasiums, hospitals with outlying buildings. And because I was a new engineer and I didn't know any better, I just used what everyone else did there, and that was masonry. So we did a lot of masonry design with steel framing or wood framing. We had high seismic, we had blast requirements for the military bases, we had stringent DSA requirements which govern schools and hospitals there, and we used masonry for all of it. It's strong, it handled all of those requirements beautifully. We weren't afraid to use high strength masonry, to have special inspection, to grout solid if we needed to, but as you'll see, it's not always necessary. But then I moved to Arkansas, and I guess that's the Midwest, Mid-South, whatever you want to call it. And I was frankly very surprised by the attitude that I found outside of California, where masonry, like I said, is just perceived as not as good as the other building materials. And not only is it just as good, just as strong and robust, it can actually be a much more economical and efficient solution. But the problem is you have to have a good design. So what are some of the good versus the bad design issues? We're referring to cost when we talk about a good or a bad design. And most of the structural masonry design today has design flaws because of the way we've just kept reusing some of the old standards without upgrading to more modern techniques. And that's also true in bidding. A lot of times previous projects are used for bidding, and again, those were designed using older standards, and so you have an inflated estimate that is probably not realistic. And the key items that are wrong are engineers are using the wrong block strength. That is a huge one, and we'll jump into that one pretty quickly. We're not using masonry that's already present in the structure. It may be ignored and then built around. And that masonry is usually there in some form or another with stair towers or shafts. When it is there and it's not used, we're over-reinforcing it. A lot of partition walls don't need masonry. We'll talk about that later too. And then investing in your choice of material for lintels can be pretty expensive if you're trying to force a material into masonry that doesn't necessarily need to be there. So if we move away from the bad design to the good design, we'll move away from lower F'(m), which is the block strength, to higher values. I'm not really going to go into control joints too much today, but that also has a huge effect on the cost of your construction. You would move away from putting them in openings and into the field of the masonry. Steel lintels should be replaced with masonry lintels. Instead of reinforcing all of your partition walls, only do those that need it. And then change our mindset that the belief that masonry needs to be load bearing. A lot of people think, oh, the wall is there and I just need to design around it. But if it's there, we need to utilize the strength that it brings to the project. So here's the order in which we'll address our topics today. Can everyone hear me okay? Okay, I think there's a mic on it here, but I tend to be a little bit softer spoken and then I go quickly and I don't want to lose anyone. So we'll start off with some structural masonry basics, move into some of the masonry systems that are out there, talk about stair towers and shaft walls, interior partitions, masonry and steel interfaces, and then finish it up with lintels. All right, so for the basics of structural masonry, why would you use structural masonry? And how can you use structural masonry? You can use it for all of these bearing walls, partition walls, shear walls, firewalls, shaft walls, like I mentioned, are going to already be there, so we need to take advantage of that. Basement and frost walls, I won't go into that a lot today. The material is inherently non-combustible. It's a finished trade, so you have tighter tolerances when you're constructing in the field. There's no lead time for production. If you're waiting for your steel shop drawings or your review, you're going to set your timeline back a little bit. Since a lot of this can be done on site, then you're not tied up with that. Because it's on site, you can adapt easily to field changes. And this is just a quote that we like to say, with masonry, you can just pick up the phone and the change can be done. You don't have to go through endless series of RFIs and back and forths and creating new shop drawings and new fabrication drawings. So this one material can be used efficiently for the structure, the exposed finish, fire resistance, blast resistance, storm resistance. We'll talk a little bit about some tornado shelters later on. Moisture resistance, acoustics, and the list goes on and on and on. And I'm probably going to beat this topic a lot, but masonry is already on the job. So if it's there, let's go ahead and use it. Masonry is sustainable. We can create block. And it's usually local as well. So local materials, local employment. It's nice to know that you're supporting your ecosystem. So for you as architects, you may sometimes be told by the engineer, this is what we're using for masonry, and that engineer has some of these mindsets of, I'm only going to pick a value from a table, or I'm going to use something that I always did. And what I'm hoping to educate you on today is some of the areas where you can push back on that and you can say, you know what, we might be able to use a higher strength block, or we might be able to not reinforce some of our partition walls and save some cost on your structure. So a little bit of the history of masonry. This building, and I'm not from Chicago, so I can never quite get the pronunciation correct, but it's Monadnock Building in Chicago. It's an example, one of the oldest examples of brick design, and it's the largest load-bearing brick building that has largest unreinforced load-bearing brick building. And this was built in 1892. It's 16 stories tall, so at that time they did not have reinforcing. They just increased the masonry on the way down. And at the base level, the walls are 6 feet thick. So it's not necessarily efficient or something that we would do today, but it just goes a long way to show you that we've been doing load-bearing masonry design for a long time. It's still standing over 100 years later. And it's just an example of the mindset that masonry can be used. At that time that was designed, there weren't even any empirical tables available. But you can see that up to 8 stories, this table of empirical data, which was, I think, around the 1960s when this was available, allowed you to use unreinforced masonry up to 8 stories in the Chicago area, which is the closest to, well, I guess Memphis might be close to here too, but the closest one up there to Springfield. And some people nowadays say masonry you can't even do a 2-story building in masonry. Well, that's clearly not the case when even unreinforced masonry 50 plus years ago could go up to 8 stories tall. And of course the Monadnock building was even taller. Sorry, that went forward before I was waiting for it to go. And today, of course, with software and updates to materials and our engineering understanding, we can go much taller and we can be much thinner. So a little bit of the history of masonry. Masonry and concrete have sort of a staggered timeline. First reinforced concrete codes were introduced in the 20s and 40s. And it was only at that time that the research on masonry structural behavior was beginning. So ACI code came out for concrete, and then in the 60s, the first engineered masonry code came out. And that is where those tables, that is when those tables would have been available as an empirical value. In the 60s, ACI was already moving forward from allowable stress design to LRFD design, and masonry has taken a little bit to catch up. But the gains that they've made in understanding in the last decades have been implemented. We have software. I mentioned that I worked for Bentley. RAM Elements is one of the programs that first introduced some software FEA, finite element analysis capabilities, into their programs. And with that, the idea of designing masonry has really taken off, because we're no longer thinking of it in old-fashioned terms of just the block and just strips of block or spans of block. We can now look at it as a cohesive element. We can look at the way the wall flexes with the wind, and we can take advantage of some of the inherent stiffness in that wall that empirical values don't really allow for. So just how tall can block go? This is a slide that most people are actually pretty surprised by when we go through it. So for maximum masonry wall height, and of course this is going to vary by your project and your location, but for 8-inch CMU wall, lightly reinforced, which as you can see at the bottom we've said is 48 inches on center, you can easily have a 24-foot high, 8-inch, lightly reinforced masonry wall. If you use 12-inch block, you can take that height up to 32 feet. And again, this is only lightly reinforced. This is only 48 inches on center. If you more heavily reinforce it, double that to 24 inches on center, you could possibly go up to 36 feet with a heavily reinforced 8-inch block, and then even up to 52 feet with a heavily reinforced 12-inch block. This example here is a high school, and the top of wall there was 51 foot 4 inches with 12-inch CMU.
How often bondings
Those are vertical spaces. What about bond beams?
As far as used as a lintel or out of plane for the wall?
In the wall, just bond beam, horizontal reinforcement.
Oh, I see what you're saying. Yeah, that's going to depend more on the seismic requirements. So this was in Wisconsin, I think. There was not high seismic. So I don't have the numbers for what it was for horizontal, but it was probably just welded wire reinforcement.
No bond beams. Wow.
At the top of the wall, yes.
And you're saying 24 feet with no pilasters?
Yes. Spanning vertically 24 feet with the support at the top. You're talking about bond beams within the height of the wall, right? So something at mid-height, yeah.
Yeah, we often see those at 8 foot and more.
Yeah, not necessary.
It's overbuilt.
Yeah, very much so. And a lot of that is just because that's the way it's always been done. People revert back to their typical details or the way that they used to do it, or the way that they know if they build it that way, they're not going to have any issues. Instead of having to actually engineer it, and they just say, let's throw a lot of steel at it and make it work. And following up on that, we do need to start designing for the actual loads. We don't need to pull from tables for who knows how old that information is. If we start looking at the actual loads on the wall, build some models in a software, you would be surprised by what masonry can do. So masonry is a system. A lot of people use the term CMU or masonry interchangeably. As a structural engineer, one of my pet peeves is when people call concrete cement. My 3-year-old son calls it a cement mixer, and I'm gonna beat that out of him. not literally. He'll know it's a concrete mixer. But masonry is the same. It's not just the CMU. There are a lot of other elements that go into it. So first you have the block itself. That's the concrete masonry unit. That's where you get the strength. And then you have the mortar, which is the glue that holds your blocks together. The rebar that goes in to take out that out-of-plane bending element of the wall. Horizontal joint reinforcement, as I was just saying, usually this is not going to be very structural. It's going to be more for crack control. But if you do get into a high seismic or a high lateral area where you have a lot of shear in that wall, then you would start putting in the horizontal reinforcement. But in most of the design I did, we didn't use bond beams for that. We just used rebar spaced similar to how the vertical rebar was. So number 4s or number 5s at 48 inches or 32 inches or whatever it required. And then, of course, the grout, which is placed where the rebar is located to turn this into a system. The rebar takes the tension and the block takes the compression in the wall. So masonry has a lot of advantages. The fact that it's simple and it can be built on site. Or it can be complex. You can go up many stories with many openings like we see here. And then when we start to try to introduce steel into it, it becomes not simple. This is a detail where we have a relief angle. We're trying to, whoever designed this was trying to relieve some of the load off the wall below and tie it back into the steel structure. Masonry is strong. It likes load. It can support its own weight. So what you end up doing here is creating an unnecessary detail and unnecessary support with the idea of trying to help the masonry when in reality you're not helping it at all. The more lightly loaded the wall, sometimes the more reinforcement that's required. And then you end up with a less redundant system. You're relying heavily on those small steel angles. Okay, so moving into that block strength, this is something that I want you to take home today. For sustainable masonry design, use what's available to you. Use what's, quote, off the shelf, what's local, and use the strength that is being provided. Historically, engineers, when they're being overly conservative, say we're just going to use the minimum block strength available, which is 1,500 psi. So when you talk about F'(M), you're looking at two different components. You're looking at the block itself, trying to use the highlighter, And then you're looking at the mortar type that connects that block together. And it's the combination of those two that give you the strength of the wall. I need to go back to that. So in the past, the individual block plus a type S mortar, this 1500 PSI was the absolute minimum, and that's what a lot of people relied on. It was very unusual to specify anything higher, even though those values were available. And then with some new updates to the Masonry Code, the 2013 edition, we actually made it even easier to achieve these component strengths. We lowered the required value of the block. Sorry, I skipped ahead. But anyway, now, the masonry block itself has to have a minimum PSI of 2,000, and with that, you don't even get a reduction with the mortar. Your component, your system value is 2,000 PSI. So now that should be a minimum that anyone is using.
I would point out the F prime M is required to be part of the construction documents set by the code. So every architect should have that discussion with their engineer to have that discussion. Are you using 1,500 or 2,000?
Right, and that's where if an engineer tells you, hey, we're going to use 1,500 block, you could be able to say, you know what, this lady came and talked to me and she said we should use 2,000 minimum, and we'll be able to save a lot of steel and possibly even use thinner block. And I don't know how the engineer will react to that, but hopefully they'll listen. But then getting these even higher values has become even easier with lower block strength. That's just because of a lot of the quality that's been provided and the better testing methods that are available. So F prime M is important because when you're looking at the design of the wall, it comes into play with everything. It's going to factor into the bearing calculations, the shear calculations, the lintel calculations. When you add it all up, you're going to get a much more efficient design. And that 2,000, even though it's the minimum, in reality, we're seeing much higher values. You may even be able to double your concrete strength, still using the exact same block that you were using and specifying at 1,500 F prime M. And here's a little cost impact analysis that we did a few years ago. This was a 4-story tall wall, and it was 12-foot floor to floor, and the original strength was 1,500 PSI, and 12-inch block was required for this. We did a little study, and just by increasing the block strength by 50%, which is 2,250, which is just barely above the minimum available, we were able to reduce that to an 8-inch CMU wall, and that translated to 18% savings on the installed masonry cost. And for this $2 million masonry contract, it was $360,000 of savings. And that was not specifying anything different than what was already on site. It was just taking advantage of the strength of the block that it already has and not defaulting to that minimum 1,500 PSI value. This is another example that we did for an 8-story load-bearing dorm. In the initial design, the upper stories, they did use 2,000 PSI, and it was an 8-inch wall. And then if they continued the 2,000 PSI at the base stories, they had to go to a 12-inch wall. So what we did is we ran it with some higher values for strength, 3,000 PSI, and we were able to continue the 8-inch block thickness all the way down to lighten the reinforcing. Obviously, if you've got that 8-inch wall all the way down, you're helping out architecturally as well. You're not losing as much floor space at the lower levels with that thicker wall. So this was another example where we were able to show some savings just based on using higher block strength. This next section is masonry codes and standards. I'm not going to get into this too detailed, but I did want to point out that in the 2015 IBC, new requirements have been added for mandated storm shelters for certain building uses. So is 2015 adopted here yet? IBC 2015?
We're still in Flint.
Okay, so when this is adopted, these requirements will be mandated. So if you're working on a school or a critical facility, these storm shelter requirements are going to be necessary. and they are pretty stout. This is a graphic of the wind loads that this is targeting, and you can see Missouri is in the darkest blue area. That's going to be the 250 mile per hour region, and your structure is going to have to be able, if it's in one of those categories, it's going to have to be able to resist those requirements. And masonry does a great job for resisting wind both in plane and out of plane, and it's a nice choice when you have to add these requirements in on top of all your regular building requirements. That was really all I was going to jump into on the codes. Masonry systems, there are many, many available. When I think of masonry, I think of a single wife wall. That's just what I used and what I designed and practiced the majority of the time. But of course, you can do a cavity wall system. You can attach masonry veneers. They can be anchored or they can be adhered. That's just in the masonry family. If you find that you do need steel, there will be times when you do need structural steel in a building. Hybrid masonry structures are now becoming much more prevalent. You may have a concrete or a steel frame and then infill that with masonry, and that's something that's available in a lot of design programs now as well. Prefabricated masonry, it's coming along. In the past 3 years since I've been with Force, we've seen prefabricated lintels used a lot. We've even seen some prefab stair towers used. The construction timeline benefits from that, because then you can just fab everything and then bring it to the site and place it, and speeds up your timeline quite a bit. But this is maybe not intuitive to people as well. When they think of masonry and they think of it as being old-fashioned and not having a lot of options, there are actually quite a few ways to use masonry by itself or with veneers or with steel to make your structure efficient. There's a lot of flexibility. Even if you do have a completely different building system, don't forget about the masonry. It can be used in almost every system in many different areas. This is just a little checkbox of where engineers do use masonry. Stem walls is actually something that I wish I had a little bit more time to talk on, but stem walls and basement walls are defaulted to concrete. Lots of times people assume they either can't get the thickness of block they need, or they think that they have to solid grout the foundation wall, but that's not true. You can use these foundation walls in all building systems for a savings. And then of course your shear, your shaft walls, bearing walls, partition walls, and those bearing walls can be interior or exterior. This is just a picture of a steel masonry hybrid system. In this case, they were using the steel for the vertical load and then infilling with masonry for the lateral load. And then the same concept with a concrete frame, which is a little bit hard to see, but you've got the concrete frame and then infilled with the masonry for the lateral. So it plays nice with the other materials. And that's just a picture of the model that was created for that system. The engineering design model. Prefab masonry panels. In this project, the contractor and the design team determined that prefab bearing wall partitions would be most cost effective for this project. So all of those walls denoted with a red arrow there were prefabbed and then placed on site. And this is a picture of what I was talking about with the prefab shaft walls. Those were all, I think they were built on site, but they were built on the ground and then lifted into place. Prefab lintels, I have a whole section about lintels later, but that's another area where sometimes it's easier to construct it on the ground or off-site and truck it in. Okay, so those were the systems that were available. Now we're going to talk about stair towers and shaft walls. Just because of the nature of multi-story buildings, you're going to have some needed towers in most of your structures. And sometimes they're not used to their full potential. So this is my only, I don't know if it's really a quiz, but my only question of the presentation today. Which of these walls, and I might have given this answer away already, which wall requires more reinforcement, the more lightly loaded wall or the more heavily loaded wall? And I think I did talk about that earlier, but masonry likes load. When you compress the masonry, it's stronger. It can resist forces out of plane better and in tension. So if you take away the load, you actually end up with heavier reinforcing in some instances. So if the wall and the tower is already there and it performs better and is cheaper to reinforce with more load, then we should definitely be taking advantage of that. This is a picture that illustrates sort of the illusion of ignoring the masonry walls. In this project, the lateral system are steel moment frames. The lateral system is steel moment frames. And the masonry walls were not considered for the lateral. But if you look at this picture, just looking at it, you can tell that those walls are significantly stronger than that steel. And in reality, the building doesn't know what you've engineered for it. It's not going to say, okay, I'm a wall, but I'm not going to take any load because the engineer said that I wasn't going to. It's going to attract that load. And those steel frames will take some of the load, but they will take a much smaller portion than what they would if there were no walls there. So realistically, the building is going to impart load on those walls. We can design without considering them, but then you're adding unnecessary steel when the walls themselves can often take the full load. So don't frame around them, just use them. The same is true for wood construction. This is a multi-story wood residence where you've got that nice stiff tower right in the middle, but you have plywood shear wall panels being used for lateral. So there are some considerations in wood design. Often you can't get all of the load back to that wall, but some of it could be taken there, and we should take advantage of that as well. This is just an overhead view of a similar project with all the stair towers in place. Okay, so interior partitions. This is an area where I think 99% of projects could save money on. People default to the idea that it's an interior partition, it has to be reinforced. And oftentimes the tables that have been used and the standards that have been used are outdated or maybe, again, just a rule of thumb that someone designed. So we've got here a interior partition wall that has a bond beam at the top, that has interior pilasters, and according to the code, if it really is truly a partition wall, then it does not have a structural function. That's the definition by the code. So it's not going to be heavily loaded. And we can take out all of these items and the reinforcing and be more cost effective. The top of wall bond beam that took out, that's not really needed in a partition wall. It's necessary in a shear wall, but a partition wall is not intended to take shear and will be detailed because the code requires it, that it cannot take loads if it's a partition wall. So the attachment points at the top will prevent that from taking load. So just by removing some of these typical elements, you're already lightening the cost of the wall. And then if we take a look at the actual code tables for partition reinforcement, this is the other eye-opening chart that people take away from this. For a seismic design category of A or B, which I think I heard someone say it's C here, so this C.
St. Louis.
C is St. Louis.
Down here.
Here is just A and B. So even a 6-inch wall can be completely unreinforced if it's a partition wall up to 14 feet tall. 8-inch wall, you can go up to 18 feet. No reinforcement necessary. There's nothing in the code that says you have to have some reinforcement in your partition walls. As a matter of fact, the code says you really don't even need it for a 16-inch block at all, up to 30 feet tall.
Would that include wire mesh?
Since wire mesh is more for crack control, no. I think, yeah, this would apply mainly to structural design, yeah.
Do these have to be raised to the top?
Yes. Yeah, this is considering a wall that's spanning from floor to floor. If it was a cantilever wall, it would be very different. If you move up to seismic design category C, an 8-inch wall is still, it's reinforced, but it's still a lot less than what I see typically. I see number 4s at 48. Sometimes I see number 4s at 96, but number 4s at 10 feet is the minimum requirement in seismic design category C for up to 18. No, yeah, 8-inch block can go up to 18 feet tall. And in seismic design category C, that's where you really start seeing the heavier concentration of reinforcement in the wall. And so it requires the number 4s at 48 minimum everywhere. So if you have a typical detail and it's saying reinforce all partition walls with number 4s or 5s at 48 inches on center, that's a significant savings cost just by eliminating that. If you're not comfortable with looking at the tables, IMI, the International Masonry Institute, actually has a free program on its website. You can just plug in some values and get some preliminary design requirements for your partition walls. This is something that could be done very quickly in a design meeting or pointed out to your engineer who may not know that this is available. And again, get you a rough idea of whether or not those partition walls are going to require any reinforcement. So masonry and steel, when they're put together in a building, can work properly, but it has to be pretty well detailed. If you start putting in steel lintels where a masonry lintel may suffice, you're going to start adding in quite a bit of coordination, quite a bit of just extra work that wouldn't be required with a masonry lintel. And there's some things that you have to be very careful about. So if you have a steel beam, you're going to have to match the finish, you're going to have to put in this infill panel around the beam. And that becomes a very weak point. So you've got this very thin face shell. Sometimes this is at a roll-up garage door, and you might actually be seeing quite a bit of potential damage in that area if things are running into it. So where the structure might actually need to be a little bit stronger, it's weaker, just cosmetically. If you try to fit a steel column into a masonry wall, you may end up with this issue where you actually can't put face shells around it to hide it. In this particular example, that's what happened. So in the final product, they actually ended up furring out the wall. So that was a huge cost addition. If they had just relied on the masonry for the column, for the support of a lintel or a masonry column, they could have eliminated that. If you do manage to get a column inside a block, the face shells are going to be susceptible to cracking at that location. This is another case study that we did where the initial project had steel lintels everywhere, and we were asked to come in and, no, I'm getting confused on which one this is. There were steel columns and there was a concrete foundation. The steel shop drawings were not going to be ready for 5 to 6 weeks. So basically, the request was if we use masonry, would it speed up our schedule? So in this case, it was more of a schedule concern than a cost concern. There were 54 columns, and it was a pretty complicated layout. So when we switched to a masonry solution, we changed to CMU foundation wall. We used 8-inch CMU load bearing wherever we could, as opposed to steel, and included a 4-inch veneer on that. It reduced the number of steel columns to 9. There were only 9 locations out of the 54 where steel were required. And the schedule was less than 4 weeks for all of the masonry, as opposed to waiting for 5 to 6 weeks for the shop drawings to even get started on the steel construction. And that ended up in an estimated $40,000 of savings in this project. And the developer liked this concept so much that they switched to this as the prototype for future sites. Okay, so the last topic that I'm going to cover is lintels. We've already talked a little bit about that in the masonry steel interface area, but when you have a masonry building, let's say you've been fortunate enough to get it spec'd out and you know that you're using masonry, it's going to be a good design, there's still this tendency to feel like we have to put a steel lintel in instead of masonry. There are 3 types of lintel options that you could use. Masonry itself, which is the best solution, I think so, architecturally and structurally. You can use steel, which is very common but generally not needed, and it makes that simple construction not simple anymore. And then precast. So if you have a steel lintel, you're going to just run into a lot of coordination issues. It has that longer lead time than masonry. You have to conceal it, so you have to think in advance. My width of my steel beam can only be less than 7 5/8 inches or 11 5/8 inches or whatever that dimension of your block wall is going to be. It's best if you can match your depth of your steel beam to masonry course depth. So you got to think about that in advance too, or else when you start to cover it up, it's just not going to look right. And then steel is very dissimilar from masonry in the way that it expands and contracts. So you start to have connection requirements that are needed. It just goes on and on and on. Also, if you replace a masonry lintel with a steel lintel, you might have a thermal bridging issue there. So I think I just went through all that without clipping. Yeah. One big rebuttal that we often get is, well, you need to shore up the masonry lintel while you're building it anyway, so we might as well put the steel there. And there's easier ways to do it, less expensive ways to do the shoring than to just rely on the steel lintel because of shoring. Yep. I actually was going to skip this slide, but we calced out that this could have been a much smaller plate than it was, and it ended up being a huge task to get that steel lintel in there. I'm just going to skip over that one. So if you do detail for steel, then you have to start taking a look at all of the issues. I already talked about that. A lot of times if you have a veneer, then you're going to be adding a shelf to carry that veneer and tying it back to the steel lintel. And if you do that, you're creating torsion in your steel beam. Sometimes that's overlooked. People don't even realize that they're going to need to design for torsion for that. But if it isn't, then your beam is going to end up being much larger than you were expecting, or maybe I've even seen people use tube sections for beams. And then trying to anchor it in, you need to have the ability for the steel to expand and contract differently than the masonry. And a lot of times that's detailed out initially, but over time, water comes into play. You may get rust. It may rust to the plate, and you're not going to have that expansion capability anymore. Where the bearing plate is anchored, we see a lot of cracks happening there. The bearing plate also interrupts the jam steel at the opening. It should realistically go full height there, and that's something that you have to take into consideration. Maybe move your jam steel out and run the risk of that not being done properly. And then oversizing bearing plates is just, again, it's one of those things where people think bigger is better, but that's not necessarily the case. Oh, and we talked about the torsion. So just some illustrations. This is an ugly face shell that was applied, and then I think what happened is the steel was too wide and you ended up with a little gap there. There's an instance where the bearing plate spalled the face of the masonry. It was not centered on the wall because I guess of modular reasons, but look at how terrible that looks. And now someone's going to have to come back in and find a way to cover that up with face shells. And you can still see the bearing plates there. In this case, it would have been much, much easier to just continue those 2 courses of masonry and use that as your lintel. Masonry can easily span 6 to 10 feet with just a course or 2. And if you had depth above it, you could get even longer spans. Where that bearing plate is tying in, it's creating that crack at the wall. In order to prevent that, it's often detailed with U-hooks in the masonry wall itself to hook around the anchor rods in the bearing plate. And it's just a lot of steel, and it's complicated to do it right, and it's even hard to fit that steel in the wall. So masonry is the easier and cheaper solution in most cases. It blends in, it's fast, it's gonna match. We can construct it at the same rate as the wall because we're not waiting for the steel to come in. You can build it in place, or you can get it prefabbed. It has significant span capabilities. And in a recent project we did, we had 12-foot lintels. This is not so typical. But they were willing to say, we're going to reinforce 12 courses of masonry, so that's what we did. I touched briefly on the thermal break. If you have that masonry lintel in there, it's going to be more thermal friendly than a steel lintel. Lintels are integral with the support, so you're not looking at all of that congestion and cutting of your jam steel there. Another crack.
We are seeing, I think you mentioned it earlier, we're seeing control joints pulled away from those jams, 16 inches.
Yeah.
And you don't need to go over 8 inches and up, just pull it away from the opening.
Right, and that's, I think I said in the very beginning, control joints is a whole other topic that I wasn't going to get into today, but when control joints are put at the edge of the opening, you are going to run into more cracking issues, so you need to move them away from the opening itself. If you move it to be lined up with the edge, like that red line there, then when you have the lintel above loaded, the full weight of that is just bearing completely down on your steel lintel. So there's a rectangle of weight up there. But if you move that control joint off to the side, the masonry can act as a whole, and that load can be distributed with arching action, and some of that load actually ends up going around the opening. So your supported load is actually just a much smaller triangle. So not only have you reduced the cost of the construction and the lintel itself, but you've had to design it for a much smaller load because you're using some of the inherent benefits of masonry. Some of the ways around the shoring issue are we've seen people use downturned angles and build the lintel on that with some sort of paper in there so that they can just slide the angle out later. That's just one example, but people get pretty creative with their shoring when they're building masonry lintels. It can be done. And then, of course, precast lintels. This is just a cord draped there. That's not a crack. Every time I show this slide, I get someone asking, what is that? Precast lintels are another easier issue. You eliminate that shoring requirement in the field, and you can have those pre-created and ready to go. But, of course, you do need some additional things like a crane to lift them up. They need to be modular with the masonry. And they do need to be properly anchored so they don't roll off. This is just one of the suppliers of precast, but it can also be built on site. That's one of the, or two of the lintels being picked up. This is a multi-course lintel, not 12 courses, but still, that was made on site and then set in place. Okay, the slide everyone was waiting for. So what I want you to take away today is that masonry should be at the forefront of everyone's mind. It is a flexible, efficient, and modern material. People seem to think of masonry as stuck in the old days where you had 6-foot walls at the base of your structure. It's just not the case anymore. And the ways that we can get to this better design is to use F''M, make sure that we use the actual value that's available, or even specify higher because it can be obtained. Time to get into the 2010s, almost the 2020s already. Design by current methods. Use software, don't use tables, don't use rules of thumb, don't use standards that have been on someone's drawings for the last 20 or 30 years. If you have masonry on a project, use it, don't ignore it in favor of another material. Don't over-reinforce your partition walls. If they are truly partition walls and they're not being used, they don't need that reinforcement. And then consider masonry strength for lintels and columns. Don't just throw steel at something because you are afraid to do the engineering, not you, but the engineer is afraid to do the engineering to see if the masonry works. There's programs out there, there's support out there. There's lots of ways to get the strength out of the masonry that it has available. Okay, so with that, I'm gonna see if there's any questions. This is my email address. If anyone had any questions that they needed to follow up with me on, I'd be happy to respond to those. And of course now as well.
Any questions for Beth? Otherwise, I have one more announcement before everybody runs out. But first, I want to make sure we thank Beth for that. That's all better informed. We can talk to our structural engineers now about that. So that's great. I appreciate it.
I told you for no.
It's not
official. What?
It said you did, right? I'm going to say it.
Okay.
We can direct that Danielle and take our tech rotation exam. And I think we've got pretty good assurances, right, that you passed your last exam. So that's awesome. Well, if you have any more information you want to just come see me. Actually, you want to think about graduate day. Appreciate it. Thank you. You signed up, right?
My stress level's gone down a little bit. You have a card?
Yes.
Better than my napkin. I was going to start designing some walls, but you had some very good points there that
got an extra one?
Yes.
Thank you. Good presentation.
Thank you.
Good to hear that an engineer is not in the mindset of over-design. I have thought that for years.
Yeah.
Okay, great. Perfect.
Yeah. Very nice meeting you,
Nice
Beth.
to meet you too.
Okay. And Jonesboro's not too bad.
Yeah, well, it's not San Diego. What was your name?
I'm Eddie Towns. I'm an architect in Springfield.
Nice to meet you.
Yeah. When I talk to my masons, because I have to tell them that when you start over, there's two things we want to correct.
Oh, no. Talk to your engineers, because they're the ones probably
well,
putting it on the
doing
drawings.
it.
Yeah.
I didn't have engineers look at that.
No. Yeah. Some of them are stuck.
Well, yeah, we're too tuned in to our old previous details from
Right.
engineers and architects that we were trained under,
Right.
and those standard details and their past experiences too. So those kind of follow along with us. And sometimes you wonder, you scratch your head. I'm not sure. So why did it crack again? Because we did this and did that, and it seemed like everything's supposed to be in place.
Yeah.
I mean, it still did.
Yeah, cracks are
Yeah.
a problem. Getting your joints located and eliminating as much steel as possible.
There
That
you
goes
go.
a long way.
Yeah.
I mean, structural steel, not reinforcement steel.
Okay.
Okay. Thanks.
I was tempted to bring up direct design. I didn't know if you had ever gotten into direct design.
No, not in this presentation.
No, I mean, I know the new version came out. And so NCMA is promoting it. I'm past chairman of NCMA. So I live and breathe the NCMA.
Gotcha. Yeah. I might have been at a little bit of a loss if you...
No. It was really, really good. As I was telling him, we just really felt we need to come back to some basics. What is masonry good at? How is it? You should have checked it out.
Run it through your system with that little picture.
Yeah, that's it. Yeah. Mark's over here. And the whole Atlanta thing is always a thing. Yeah, that's the whole issue. Chef Steele in there, it just looks bad, you know. So,
Yeah.
So I did like that. And I like the aspect of a little prefab and on site, prefab a lot on site. It's kind of one of the things, prefab, especially if you have the applications and you got things. So, yeah. That's true. That's true. Yeah, I know. Well, I appreciate it. Yeah. Didn't have quite a few things. I can go find the cake. All right. You can let me go. Are you heading back? Really?
Yeah, I'm afraid that's
Good.
I got the job figured now.
That was Mike and Dave's
It is, but it's, most people don't want to use it. It's a feast for you now. Yeah. It is just awesome. And set up around it. And it's able to really good, good air installation. He does it. Yeah, it's very easy to make sure that
corrugated, yes, yes. John Sick. Oh, I know. I always get yes, he does it all the time. Not
how's your mother's presentation?
She was getting all that extra. Fine stuff. And then she played